Okay, so today we're going to talk about Kelvin temperature and CRI. These are the two factors that that you're going to want to know and be able to explain to your customer so that they understand why they're getting better light quality. The two main benefits that you're going to be selling are that people are going to save money and use less power, but then also that they're going to get better light quality. Okay, so Kelvin temperature and CRI are the light quality issues that you're going to want to talk to with your customer. Kelvin temperature is color. Okay, that's all it is. It doesn't have to do with temperature, even though it sounds like it and has the word temperature in it. It doesn't have to do with temperature. It has to do with color. Kelvin temperature is measured in the thousands. Okay, so typical examples: your regular incandescent light, the regular Thomas Edison type light that we've been using for 100 years or so. That is Kelvin temperature of 2700. Okay, 2700. That's your typical incandescent light. It's a fairly yellow light compared to fluorescent. Fluorescent lights, the most common of the fluorescent light temperatures are, fluorescent lights can be made in any color temperature, in most color temperatures. They can be made to be 2700, so they look exactly like incandescent. Okay, and that's the compact fluorescents. A lot of times we'll use 2700 if we're replacing, let's say in a hotel, we're replacing their incandescent lights with a compact fluorescent. We want to use the same color temperature so it doesn't change anything. Restaurants also may want to use 2700 because it's a more yellow light, and the more blue the light gets, the worse people look. So a lot of times they don't want that in a bar or restaurant. So 2700 is incandescent light. Fluorescent can be 2700, 4100, or 5000. Those are the most common of the fluorescent color temperatures. So if you see a fluorescent light that's almost a blue-white, that's usually a 5000 Kelvin temperature. Okay, and that's the most would be the most typical. There are some other types of light going from the low end of the spectrum. Low pressure sodium is the exterior lights that are very orange yellow color. Those are 1600 Kelvin. So that's about as low as we get in the usable light spectrum for lights that are lighting things. High pressure sodium runs typically 2050. Okay, so you can see it's getting a little bit wider as it gets up to the higher spectrum levels. And then metal halide, which it actually can run 5000 to 10,000 Kelvin. And what that is the light being almost blue purple color. So a blue sky, for instance, blue sky is, if you look at blue sky, that's about 6500 Kelvin. Okay, and then if you've seen the new headlights on cars, some of them are very blue or blue purple color. Some of those can be 7000 or 8000 Kelvin because they're getting up even higher into the blue and purple spectrum. Okay, white sky, like a cloudy white sky, can actually be even higher spectrum. It can be 5000, 10,000, even 15,000 Kelvin because it's the color kind of goes off of the chart of what we see and goes into the white spectrum. But again, Kelvin temperature is just color. Now, the human eye can use the blue-green spectrum better than the red or yellow spectrum. So what that means is the human eye, what we can do is go to the bluer lights, and the human eye can use them better, so we can actually get more usable light with less wattage. That's why the headlights on cars are going up into those 7,000, 8,000 Kelvin spectrum to allow them to be able to see better with the light. We also like to use 5,000 Kelvin if we have a sample like a linear fluorescent. If we can, we like to go to the 5,000 Kelvin. We need to make sure to let the customer know that it's going to be more blue, and that's a good thing, so that they don't surprise the people that work in their facility come in and suddenly the lights are more blue and they complain about them. They want to make sure to let the customer, their the people working in their building know ahead of time that blue-green spectrum is a better spectrum. It's more usable light. It's better to work under and with, so that when they see the blue light, they're not shocked by it. That's Kelvin temperature. Kelvin temperature again is measured in thousands. It goes from the lowest being probably low pressure sodium at about 1600 up to about 5000 Kelvin for the usable types of light that we use. Sometimes you'll even see 6000 Kelvin for certain places, but 5000 is probably about as high as we usually go for room lighting and for street lighting. Okay, Kelvin temperature. Now CRI, color rendering index, is CRI. Okay, so not to confuse these two things. Color rendering index is a scale that goes from 0 to 100. Okay, color rendering index, or CRI, means color rendering index is how well the human eye can render color. So for instance, I can see that this is blue. Okay, I can see that this is green because the color rendering index in this office is relatively high. If you took these out under a low pressure sodium light the very orange lights, you wouldn't be able to tell if this was green or gray or this is blue. If you see a car under a low pressure sodium light, a lot of times you can't tell the color. Okay, and the reason for that, low pressure sodium on the scale, again, the scale goes from 0 to 100. Sunlight is 100. So if you're buying a car and you want to see the color of it, you want to look at it in the sunlight because the color rendering index is so good. It's 100, so you can really see what's happening with the car. That's a real full spectrum type of light. Low pressure sodium is 5. Okay, so 5, again, is extremely low. You wouldn't want to buy a used car from someone who was selling it under a low pressure sodium light. High pressure sodium, 27, so it's getting better. And typically the color rendering index goes along with the color of the light. The higher the Kelvin temperature, typically the higher the color rendering index, how well you're going to be able to see color under that light. Metal halide lights run 65 to 70, so they're pretty good. And also T12 is about 62 typically, so it fits right in here on this chart. And then T8 fluorescent, which is what we're going to in most interior applications, and induction. But T8 fluorescent can be anywhere from 75 to 98. We are actually, the requirements under our programs is that we use a CRI on our lamps of at least 84. So basically what we're doing is bringing people's CRI up to a higher level, using the same wattage or less wattage, and so that gives them more usable light. So if we went from a low pressure sodium that has a CRI of 5 and we put in a T8 light that had a CRI of 85, let's say, they're going to have a lot better usable light because the color rendering is going to be so much better. Okay. Induction also fits. It's actually almost the same as T8 fluorescent. It runs color rendering index. We actually have requirements of using at least 84 CRI on induction as well. So it's basically a fluorescent type of light, and also is getting the color rendering index up. So again, color rendering index is 0 to 100, and the higher we get that color rendering index, the better for the customer as far as the quality of light. Okay, not to be confused with Kelvin temperature. Kelvin temperature is in the thousands. It goes from about 1600 for low pressure sodium up to about 5000 for some of the bluer type of T8 fluorescent that we use. Okay, and then again, incandescent is 2700 fitting in there. That's the difference between color rendering index and Kelvin temperature. One of the other types of lights that's very much like incandescent is halogen, and halogen light runs a 3000 Kelvin temperature, where the induction is 2700. They're treated almost the same under our programs. We replace them again, typically with a fluorescent that has a higher Kelvin temperature and also typically a higher CRI for most of the products that we're using. Okay, good luck.